the channel. So today's topic is about AdaBoost Classifier, which is another machine learning algorithm, and this is an ensemble learning method, just like random forest. So we can implement it using Scikit-Learn. So if you need to know some theory about it, check the Scikit-Learn documentation. I will get started with the code. So as usual, import required libraries. So pandas. Import matplotlib. From sklearn model selection, import test script from sklearn ensemble, import AdaBoost Classifier, and finally from sklearn import matrix. Okay, so we have imported the required libraries. Then I will load the dataset for this task. So the dataset is called 𝗕𝗢𝗥𝗢𝗥 dataset. So let's load it. 𝗕𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥𝗢𝗥 𝗕𝗢𝗢𝗥𝗢𝗥𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢𝗢 It has a lot of features. Okay, let's see _df.info. So 13,611 entries and 17 columns, and I can see that all of them are non-null, so there is no missing values in this dataset. Let's check the shape. Okay, we can see here, same here, and this is our target column, last one. So let's check the unique entities in this column. So I can see Sikar, Barpunia, Bombay, Cali, Horos, Sira, Darmasun. So these are types of beans because this is a drive-in dataset. You can also check the fellow counts. Okay, so this one is present for the most number of times, over 3,500 times. Then you can see the values for other types. Okay, so let's perform processing because these are categorical values. We need to convert them into numerical values. Perform pre-processing. _df.replace. So to replace, I will just copy this. So we need to replace this with this numerical values. So 1, 2, 3, 4, 5, 6, 7. So 0 to 6. Then df.head. Okay, let's check here first. So it says Sikar. In the first 5 rows, So I think we'll see 0 here. Okay, we can see 0. Then just recheck these things. So since I didn't change the serial here, I think I'll see from 0 to 6. Yes, I can see that. Let's also confirm this. Okay, so now instead of the star motion, I'm getting 6. Okay, so I think this is also correct here. So the next task will be separate features and process. So our last column is the target column. So we can drop it from the features, then and _df.lock. That column only in the class. Okay, that one worked well. Then please put the dataset. So xtrain, xtest, _𝗏𝗏𝗏, _𝗏𝗏test. Train test split. So x, y, test size 0.3, train size 0.7, random state 1. Then we can check the length, xtrain, then xtest, _𝗏𝗏train, and _𝗏𝗏test. Okay, something is wrong. Oh, sorry. Now it's okay. So we have more than 9,500 samples in the train set and more than 4,000 samples in the test set after 70% by 30% split. Then we can apply our AdaBoost classifier. Apply AdaBoost classifier. So let's call it ADB. And let's check the parameters that we can set. So this is the number of trees, I think, in estimators. Okay, they're calling it the maximum number of estimators. Then there is learning rate, algorithm, random state. Okay, so let's change some of this. So I will use 100 instead of 50. Then algorithm, I'll use this one. Random state. Then adb.fit, xtrain, _𝗏𝗏train. Okay, so I have fitted with the training data. We can check the accuracy. So print accuracy on the train set. So round adb.score, xtrain, _𝗏𝗏train. Test. Okay, so we are getting the accuracy for both sets, both of our sets. So and they are both 87% point something, so very much identical. So we can now plot confusion matrix. Confusion matrix. Test here, then I can get the predicted labels. Then matrix dot confusion matrix. I'm going to provide the 𝗦test and 𝗦pred. Then matrix dot sim adb dot classes. Then this dot plot cmap fm hot then color bar false. Text size. Prediction, font size, font weight. This is bold. Copy and paste. This is ground truth. Confusion matrix. Y label and title. Font size 30. Okay, so this is how our confusion matrix looks like. Okay, so these are the correct predictions in the diagonal for all the classes. We have 7 classes, I think. Yes, so 0 to 6, 7 classes, and I think this one has some more wrong predictions in class 1, then probably in class 3 as well. This is a big number, and then I think this one is not good, so this is a very big number. Okay, so let's test it first, then I can just copy this. Okay, and then this. Okay, so now we have replaced these numerical labels with the categorical labels. Okay, I think x-axis got a bit messy. So we can use this. This is vertical. Okay, now we can clearly see them. Okay, let's check 𝐀𝐝 score. So I test 𝗦𝗘𝗞𝗘𝗥 and average macro. Okay, so 𝐀𝐝 score is 88.37%. You can also print classification report. Matrix.classification report, 𝗦Test, 𝗦Print. Okay, so I think this one looks good. Then we got these values are slightly lower. I think it's because this thing. This one also looks good. Then this again, this one is slightly lower because we have more wrong predictions there. Again, this too doesn't look good because of these high values, high wrong predictions. Okay, let's check feature importance. So pd.dataframe adp.feature importances index adp.feature name columns, let's call it importance. Okay, so these are the importance values for all our features. I think we have how many? 17, because this one is target, not features. So probably there are 17 values here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16. So we have 16 features here. We can do a bar plot for them. So plot feature importance. Okay, so the most important feature is convex area, which is this one, I think. Then we can see others as well. So this is the second most important, shape factor 1, then other, so appearing one after another. Okay, so finally I want to show one more thing. So let's check the parameters once again. So you can see it has an estimator parameter, which is by default none. And I want to see some of the description. So if none, then the base estimator is decision tree classifier with max step 1. But we can use something else than decision tree. So for example, let's use random forest to see what happens. sklearn.ensemble random forest classifier. Just change the name estimator. Sorry, random forest classifier. let's provide n estimators 5, max depth 5, random step 1, and I'm keeping this on fixed. Let's fit out data, and with our estimator is now random forest classifier instead of decision tree, which is by default. So now we are fitting out data to this one. Okay, we have fitted the data. Now let's just check the accuracies. So instead of LDP, now this will be ADBRF. Okay, so now we have an accuracy of 96% and 91.5%. Previously we got how much? 87.76 and 87.46. So this is more close to each other, and here we are getting a much larger difference between the accuracies of train and test set, but we can increase the accuracy using random forest instead of decision tree. Of course, these values can be played around to see if we can minimize the difference. So that's all I had for AdaBoost Classifier. We can implement it using Scikit-Learn. So I think that's the end of this video. Thanks for watching.